Okay, so we're on the next step of the Civic Turbo build for the D16Y7 block. Right now we've got the pistons and the rods assembled. So quick recap of that, I'm using YCP pistons from Speed Factory along with Speed Factory specialized rods designed for a higher compression ratio without having to notch the block or the girdle, supposedly. We'll see how that goes. These are non-press fit piston rings, or sorry, not piston rings, rod pins. These are set with C-clips, so it's pretty easy to do. You don't have to have a shop press them for you. You have your own press to do it. You've got your 3 ring sets, ring 1, ring 2, coil cleaner ring. So when I was assembling these, one of the most suggested things to do for the compression rings themselves, ring 1 and 2, is to sand down any sharp edges on them, and those sharp edges are mostly going to be the very top edge and bottom edge of the ring itself, as well to check the actual gap spacing on the sealing point of the ring. If you don't have feeler gauges that go down to 1/1000th of an inch, whereas I don't, you can use the light method where you take your ring and you press them together and hold it like it would be sealed on a piston. Look at it in front of the light, and then if you see light through the mating surface of the ring itself, you can kind of figure out where you need to sand it down a little bit to make those two mount together easier. What I found with mine was that most of that unevenness was from the coating itself, and I used 400 grit wet dry sandpaper to sand it down. Basically, once I took the coating down a little bit on those mating surfaces, they lined up and basically no light would pass through them. You're not going for absolutely perfect perfection because, I mean, doing it this method, light begins to bend around objects that are so close together that it's going to be really hard to pinpoint where your unevenness is. So as long as you're getting a good line of no continuous light between them, it should be good. And then, like I said, I went through and took down just a tiny bit off these edges to make them a little smoother. And the most suggested way of assembling these rings is not by pushing one end on and wrapping it around. It's actually to expand the ring by holding both ends of it and take it down to the level it goes on and let it close. This will prevent creating a torsional twist on the ring itself, where if I had taken this and put it here and then bent it all the way around to get it down, you basically create a pre-stress in the metal itself by bending it around the piston, supposedly. There's some debate as to that, but I'm not a material scientist. So I've got all 3 sets of the rings on. I've got my pin and my rod on. I've got my bearing cap for the rod off. And what I'm going to do is I'm going to put my bearings in. I'm using King Racing bearings, one of the more common and suggested bearing sets for doing these kind of builds. So per the instructions of these rods, which are doubled for another motor, the bearing tangs themselves go to the exhaust side. So I oriented my tangs for each one of these to the exhaust side of the motor if I'm looking at my motor. And the lineup for the arrow on the piston itself is towards the flywheel per the directions of the manufacturer. I know there's some debate as to what the arrow actually points at, but being that these are aftermarket parts, these are specifically designed in this specific type of motor build to point at the flywheel. There is another motor that these double up and are able to be used in, and they actually point at the timing because the exhaust and intake are reversed. This is all based on which side the intake and the exhaust is on. So mine are arrow to the flywheel and tangs to the exhaust. So I did that when I assembled them. What I'm going to do is come through and clean off these bearing mounting surfaces. I've got those clean. I'm going to take my bearings, make sure they are clean as well. They usually ship them with shipping grease to keep them from corroding or anything like that when they're in shipping. So you want to take most of that off before you actually try to assemble these. And take your tang and stick your tang in first. line up the mounting surfaces and kind of just press it in. If I can get this lined up correctly. Now, as you can see, mine did not line up as well as I wanted. That's why I've got a rubber mallet nearby to kind of just take these, tap them around to where I want them. And you will notice, if you actually read the instructions on these King bearings, if these are what you're using, as a lot of these bearings, they're not going to sit perfectly flush with the mounting surface. They're actually going to sit a little above it, and that is, per the instructions, it's a crush zone basically, so the bearing gets crushed a little bit into place when you torque these down. So I've got one in, to get my second one in, making sure everything's cleaned off. As you can see, I'm not using assembly lube yet. We don't need to put assembly lube on the inside of the bearing. I'm going to do the same thing, line this up, slide it on. And you may notice a little bit of coating or bearing material comes off when you do this. So it slides past the rod, and that is perfectly fine. You just want to make sure you clean those up before you actually put them in the engine. So, there we go. So we want to make sure we align them in line as much as we can. Make sure we're sitting very straight. So then, to reference the torque specs per the rod kit for this, torque specs for these ARP, these 3/8" ARP 2000 1.5 UHL bolts are 55 foot-pounds. That is the stretch torque spec. If you read your shop manual, it's going to call out your connecting rod bearing cap nuts as 23 foot-pounds. So what you're going to want to do is torque these down to 23 foot-pounds, which you're going to put them in, finger them tight to get them in alignment. You don't want to start twisting one on and actually get it tight before you do the other one. They need to seat correctly on the alignment pins here. So you want to make sure that's on, you get both your bolts on, finger tight all the way down, and then tighten them up, going back and forth as you tighten a few rotations each way, and then you'll go to your 23 foot-pounds, and then once you do both of them, go back to the first one and do the 55 foot-pounds for this specific set of rods. So I have already done that on one of mine. I'm just going to do a quick explanation of how to get this going. So what I chose to do, you can do either direction. I chose my compression ring 1 is going to be groove open on the arrow side, so compression ring 1, and compression ring 2 is going to be groove open 180 degrees away. So if I push this out, you can see groove on ring 1. I pushed out the other way. You can see groove on ring 2 is 180 degrees over, and you always want to do that just to prevent any loss of compression where these two to both align over each other and have a slight leak. It'd be much easier for your engine to lose compression. It's not necessary to align the rings for your oil scrubber rings. You can just leave them as is. They don't actually compression fit into the cylinder. They're just there to clean up all that oil. So I'm going to make sure to check this again, 180 degrees apart. Doesn't need to be perfect, but we want to try and make it as best we can. We've got our ring compression tool here. I'm going to tighten up a little bit. There are a few different versions of this tool. This is one of the cheaper, easier ones to get your hand on at pretty much any auto parts store. Pretty simple as to how it works. Just put it in, tighten it down until it won't tighten anymore. You want to make sure you've got some of your pistons sticking off the bottom so you can align it into the cylinder. So I'm putting this in cylinder number 2. 1, 2. Before I do that, I'm going to take my assembly lube that I've been using for all my contact parts. I'm going to put some on this bearing. Nice continuous line of it. And then I'm going to take this, line up for this piston set, arrow to the flywheel. I'm going to gently set this down into the cylinder. Oh, actually, I forgot what I did on the first one. I actually took some of this bearing lube, and not bearing lube, but assembly lube, and ran it on the inside of the cylinder wall. Kind of just lubed up the surface of the cylinder wall. What's our time at?
10:26.
Jesus fuck. So we're going to wrap this down, basically. We get that on. We're nice and lubed. We want to make sure all of our contact parts have some kind of lube on them. So then my little kit here is actually going to sit fairly well on there with that little bit of the piston sticking out. I'm going to push it down and in. It might hit a restriction. Always check what you're being restricted against. So I'm going to come and I'm going to flip my motor stand sideways so I can see where my rod is. And I'm going to take my rubber mallet with a wooden handle and gently tap the piston in. Shove that. Piston went right in. I'm going to move it around and see that I have basically no play. I have some rotation I can do because I'm not mounted yet. But side to side, it does not move, which is what you want. So the rest of this past here is pretty much just coming to the bottom side, getting the rod to line up with your crankshaft so you can get your rod cap on. You're going to put assembly lube on that. As well with these ARP rod bolts, you're going to take your ARP lube and basically Loctite. You're going to put it onto your threads and under the head of the bolt. These are 7/16 bolts. So, yeah, American, weird. You're going to put them on there, and like I said, you're going to go finger tight both of them to seat the mounting surface. And you're going to go back and forth, little tight, little tight, little tight, little tight, until you get to being able to torque to the 23 foot-pounds per the spec. And you want to make sure that when you're putting these in through the finger tight process, there are no restrictions. If you're putting this on and for some reason it stops and you need to use the wrench, if it doesn't freely turn, something is either galled up on the threads or in the rod, or something's not aligning correctly and you don't want to continue. You want to take it all apart. You want to start over, check your threads, make sure they're clean, check the rod threads, make sure they're clean, and you want to, if need be, take the rod and the bolt and make sure they seat together without being in the engine. And that is about it. This is, I think, step 4 now for this, so we're going to get all 4 pistons in with their rods, and the next step is going to be getting the head on, which we've got in the corner, remanufactured head, with a dirty ass valve cover, the valve cover. We're going to get that on. That's going to be the next step. So subscribe, follow, comment, questions, all the above. Thank you.